Hello, I am Mohsen Marafat with Telai Technologies. I wanted to take a few minutes and talk to you about an important anniversary in the field of electrical engineering and all the technologies that follow. It was exactly 200 years ago when the Danish scientist Hans Christian Ørsted published a paper in which he related electric events to magnetic phenomena. This was based on observations, basically on a magnetic needle and a compass. That if you have a wire conducting electricity nearby, you would observe a deflection in the magnetic needle. And the deflection depends on the amount of current and its direction. So this paper was published in April of 1820. It was immediately a sensation. People like Michael Faraday picked it up. And Luigi Galvani, within a few years, perfected an instrument called a galvanometer for measurement of electric current, which we use to this day. So just focusing on one of the basic elements in power electronics, devices that are known as field effect transistors, these were based on silicon until recently, and the performance for many applications is lacking. So there's new technologies, including gallium nitride, replacing the silicon in the substrate, that allows us to regulate the power going to a load at much higher levels with much higher switching frequency, which is one of the essential features of these devices. The method for checking the electric current was to have a shunt resistor, and by monitoring the voltage across that, we would know what the value of the current is. Now, with GaN devices at higher frequencies, this device, because it intrudes into the circuit, it actually introduces some parasitic noises at high frequencies. Besides, because it is part of the circuit, for high voltage application, the fact that it's not isolated is a major issue. We at Telai Technologies have been working for several years to devise a new solution. Our solution effectively is based on a non-contact device that can be placed basically on top of the circuit or on any trace of interest. And that way we give the designers the ability to monitor the current in many places non-invasively and very precisely. Our performance requirement for these devices have been, first of all, to accommodate a wide range of frequencies, from DC to 5 to even 15 megahertz. GaN devices and the industry are heading that way, so the proper current measurement and monitoring technologies need to catch up with that. In addition, we want to be able to handle higher powers and do so in a precise manner. So our goal has basically been to mimic the performance of lab instruments, such as the Tektronix current probe, that is a few $1,000s, a very nice lab instrument, but you want to be able to mimic that performance as closely as possible with a device that is mass producible and low cost. I invite you to come and visit us at Telai Technologies. Our website is tel-i.com. We would like to share some of our reference designs with you. We have developed several system design kits for various applications. We would be more than happy to work with you on an SDK specifically for your applications. I look forward to talking to you. Thank you.